Adrift Decameris, and we're here to clean up the ocean.
So basically there's these 5 jars in the ocean which picks up the garbage in the ocean, and basically what we want to do is go to those 5 jars, or at least one of them, and collect as much garbage as we can from it.
There is a big current that makes a big circle in one area and collects all the garbage and wildlife in surrounding areas of it. And
So we have KT foam because it is more dense than the other foams, and we have 3 pontoons to keep it from tipping, and we have a rock to keep this from tipping it so it faces up, and we have the net, which is made out of a shirt, and some pool noodles to help keep it up, and we have this crane that holds the net and makes it so it can turn side to side.
The net picks up the garbage, and when we pull the hydraulics, it goes up and down in the water, so we can pick it up and put it on top of the boat. When we pull the hydraulics, it pulls the net up, so we can pick up the garbage and bring it to the land.
buoyancy is an upward force against the water from any certain object. Buoyancy is when an upward force pushes up against the object, like KT foam. It has air pockets, and it's more dense than any other foam.
For our boat, buoyancy is important because we have a lot of weight on it, and we need it to stay afloat for it to pick up the garbage. For our boat to stay afloat, we have air particles in these pontoons, and which makes the boat less dense, so it will stay above the water. Inside these air pool noodles, it has a lot of air particles for it to stay afloat on the water. Now I'm going to be talking about temperature. When the water gets hot, the particles in the water move around faster, so the boat has an easier time to move. And when the water gets cold, the particles start freezing up, and the boat will have a hard time moving.
Flow rate and viscosity are similar because viscosity is like when it's more viscous, it's thicker like honey, and when it's less viscous, it's like water, it's runny. Once you put honey and water down a ramp, honey will take a longer time because it's more viscous than water. Water would go down faster because the particles have a better flow rate than the honey, because than the particles, they stick more together than the water. It doesn't stick, the particles don't stick together as much.
I'm going to be talking about fluid properties. Properties of fluids determine how fluids can be used in engineering and technology. The fluid properties that we are focusing on are density, fluid pressure, hydraulics, viscosity, temperature, specific weight, specific gravity, and much more, but those are the ones we're focusing on. I will be talking about density. Density is what makes an object float. A substance is mass per volume. Our boat is less dense than the water because the particles inside our boat are more spread out and less dense than the water.
I'm going to be talking about fluid pressure. What fluid pressure is just like solid surfaces, fluids can exert pressure too. Like for example, if you were submerged in water, there'd be water on top of you, and basically that would be the fluid pressure because it's pushing down on you using gravity. And the more water there is on top of you, the more pressure there's going to be. In our hydraulics, the water is trying to get out everywhere, and where it can only go is through the tubing. And if it's here and you push it, it would only go to this tube. And that's how our fluid pressure in our hydraulic works. Hydraulic systems use an incompressible fluid, such as oil or water, to transmit forces from one location to another within the fluid. Just like in our hydraulics, if you push this tube, the water would only go through this, and basically this would push out, but in this situation it isn't because it's leaking. And you push, and then this side goes like that. If you push this one would go up. For our blueprint, our measurements were for the middle pontoon. For the width, it was 7.5 centimeters, and for these two pontoons, the left and the right ones, they were 7 centimeters in width, and in the length for the small ones, it's 19 centimeters, and I'm pretty sure the length of the middle pontoon was
29.
Yeah, 29 centimeters. And for a height for all of them, it'd be 9 centimeters.
The materials we used for our boat was tape, KT foam, syringes, 2 syringes, scissors, hot glue gun, and cardboard.